Alright, so let's talk about robots. For decades, movies have sold us this incredible dream. You've seen it. C-3PO from Star Wars, a golden protocol droid fluent in over 6 million forms of communication, always there with some slightly anxious advice. Or Rosie the robot from the Jetsons, zipping around on a single wheel, keeping the house spotless and the family in order. These weren't just machines, they were characters, part of the family. They were the ultimate helper, the AI companion that could handle the chores we didn't want to do, freeing us up to live our best futuristic lives. But then you look around at the real world. Our reality with robots has been a little different. A little less rosy, a little more Roomba. Don't get me wrong, a robot vacuum is cool. Most of the robots we see are highly specialized. They're bolted to the floor in a factory, welding car parts with incredible precision, or they're delivering packages in a controlled warehouse environment. This gap between the dream and the reality is massive. It's the difference between a generalist and a specialist. We have machines that can perform surgery with more precision than a human hand or explore the surface of Mars. But the generalist, the humanoid robot that can walk into any random human environment and just figure things out, that's been the holy grail. Enter Tesla, a company known for electric cars, solar panels, and some pretty ambitious tweets. At their AI Day in 2021, Elon Musk brought out not a robot, but a person in a robot suit dancing on stage. It was kinda weird, a little cringy, but it got the point across. They called it Tesla Bot, and later, Optimus. The goal was to build a general-purpose humanoid robot designed for mass production. So, what is Optimus supposed to be? At its core, it's designed to be an autonomous, bipedal humanoid robot capable of performing unsafe, repetitive, or just plain boring tasks. Think about all the manual labor that happens in the world, from screwing bolts onto a product in a factory to stocking shelves in a warehouse or even carrying your groceries. Tesla's big idea is to create a machine that can eventually do all of that. The humanoid part is key here. The world is designed for humans. Our doors, our tools, our workspaces, they're all built for a creature with 2 arms, 2 legs, and a certain range of motion. So, building a robot in our image makes a lot of sense if you want it to operate in our world without rebuilding everything. It all starts with the brain, and in this case, the brain is a direct descendant of Tesla's automotive AI. The robot is powered by the same full self-driving computer that you find in their cars. This is a huge deal. Instead of starting from scratch, Tesla is leveraging the years of development and real-world data collection from its vehicle fleet. The system uses a neural network approach, processing massive amounts of visual data from cameras to understand and navigate the world. For Optimus, this means it sees the world, identifies objects, and makes decisions using the same core technology that a Tesla car uses to spot a pedestrian or a stop sign. Moving down from the brain, you have the body. The design philosophy here is all about being human-like but not necessarily human-identical. The robot stands about 5'11" and weighs around 125 pounds, a size and weight that's manageable and safe for operating in human spaces. The real magic is in the custom components. Tesla is designing its own actuators, the motors and gears that act as the robot's muscles, from the ground up. The hands are probably one of the most impressive and critical parts of the whole system. A human hand is a marvel of engineering, and replicating it is incredibly difficult. Optimus has hands with 11 degrees of freedom, meaning they have a high level of dexterity. They're designed to be able to handle a wide variety of objects, from something heavy and bulky to something small and delicate, like an egg. Finally, you have to power all of this. Optimus runs on a battery pack which is integrated into its torso. Again, this leverages Tesla's deep expertise in battery technology from its cars. It also has all the connectivity you'd expect, like Wi-Fi and LTE, so it can communicate with other systems, receive software updates, and be controlled or monitored remotely. The movement of Optimus is not based on old-school rigid programming where every single joint angle is pre-calculated. Instead, it uses a more modern AI-driven approach. Tesla's team uses a method called imitation learning or behavioral cloning. They have a human operator perform a task in virtual reality or by physically guiding a robot, and the AI watches and learns. This learning process is what allows Optimus to perform tasks with a certain level of grace that has been missing from many previous robots. You can see it in the demo videos, the robot walking, picking up objects, and even doing yoga poses. The movements aren't perfectly human yet, but they're getting smoother and more natural with each update. Beyond just moving, the robot has to understand its environment. This is where the vision system, powered by that full self-driving computer, comes in. Optimus is equipped with multiple cameras that give it a stereoscopic view of the world. The neural network processes this video feed to create a three-dimensional map of its surroundings. It doesn't just see pixels, it sees objects. This spatial awareness is fundamental for any robot that needs to navigate a cluttered, unpredictable human space safely and effectively. The end game is for Optimus to be able to receive a simple command, like sort these packages by color, and figure out how to do it on its own. Now for a dose of reality. Building a general-purpose humanoid robot is probably one of the hardest engineering challenges in the world right now. The first big one is the problem of the long tail. You can train a robot to handle 99% of common situations, but it's that last 1%, the weirdly shaped box, the slippery floor, the unexpected person walking by, that can cause the entire system to fail. Another huge challenge is the physical interaction with the world. It's one thing for an AI to process images and drive a car, but it's a whole other level of complexity when a robot has to constantly touch, grasp, push, and pull on things. Every interaction with an object has physical consequences. If you grip a plastic cup too hard, it crushes. If you don't grip it hard enough, you drop it. Then there's the issue of safety. This is non-negotiable. If you're going to have a 125-pound machine walking around a factory, or eventually your home, it has to be flawlessly safe. And finally, there's the energy problem. Humans are remarkably efficient. Replicating that with current battery technology is tough. So, where is Optimus now? Since that initial, slightly awkward reveal with the person in a suit, Tesla has been giving us regular updates, and the progress has been legit. The first walking prototype, which they showed in late 2022, was a bit slow and unsteady, tethered for safety, but it was a real, untethered robot walking on its own. Fast forward to today and the latest demonstrations are in a completely different league. The Gen 2 Optimus is significantly more advanced. The most recent wow moment was a video showing Optimus folding a t-shirt. Sure, it was slow and methodical, but the fact that it could manipulate a soft, deformable object like clothing is a major milestone. Tesla has also confirmed that they are already testing Optimus units in their own factories. They're not replacing human workers yet, but they're using them for simple material handling and logistics tasks. This dogfooding approach, using your own product, is what helps accelerate development and pushes the robot to become more robust and useful. Tesla isn't the only player in the advanced robotics game. For years, the undisputed king of impressive robot videos has been Boston Dynamics. Their robot, Atlas, is an absolute beast. It can run, jump, do backflips, and perform parkour routines that are mind-boggling. Atlas is a marvel of dynamic control and mobility, designed for agility and power. So how does Optimus compare? Well, they're playing different games. Atlas is like a world-class Olympic gymnast. It's built for peak performance in short, explosive bursts. Optimus is being designed to be a factory worker. Then you have older legends like Honda's Asimo. For 2 decades, Asimo was the face of humanoid robotics, a pioneer and goodwill ambassador. And now, a whole new wave of competitors is emerging. Companies like Figure AI and Agility Robotics with their robot Digit are focused on commercially viable humanoids. Optimus's main differentiators remain its deep integration with Tesla's AI stack and its relentless focus on scalable manufacturing from day one. Looking ahead, the roadmap for Optimus is both ambitious and logical. The immediate next step is to continue increasing its capabilities within Tesla's own factories. Once proven inside Tesla, the next phase is offering it to other manufacturing and logistics companies. This would be the first major commercial rollout. After the industrial phase comes the long-term vision, the consumer market. This is the sci-fi dream we started with, the robot that could one day come into your home. A robot that could do laundry, cook, clean, or provide assistance for the elderly would be one of the most transformative consumer products ever created. When it does arrive, the impact could be profound. On an economic level, cheap, abundant, automated labor could lead to an era of incredible abundance, making things more accessible to everyone. It could free up human potential, allowing people to move away from dangerous and repetitive manual labor and focus on more creative, strategic, and interpersonal pursuits. Of course, a transition this massive also comes with huge societal questions. What happens to displaced jobs? How do we ensure economic benefits are shared broadly? The technology is moving fast and our social structures will need to adapt just as quickly to ensure a positive outcome for humanity. Ultimately, the dream of the robot helper isn't just about avoiding chores. It's about augmenting humanity, giving us tools to build a better, safer, and more interesting world. It could accelerate scientific research, care for our sick and elderly, explore dangerous environments, and unlock a new level of creativity and productivity. The journey of robots like Optimus is one of the most important technology stories of our time. It's a story about the intersection of hardware, software, and our deepest aspirations for the future. And it's a story that is just getting started. It's going to be fascinating to watch.